And now let's zoom out of the specifics of ChatGPT and think more broadly about the LLM and the AI landscape, both currently and going into the future. So we'll start by thinking about what are the key companies, the key players in this large language model game at the moment. So the top player at the moment, of course, is OpenAI. That's the creators of GPT-3 and ChatGPT and so on. And one reason they're ahead is because they made this big bet on large language models in about 2016, 2017. They saw that the smaller models were doing seemingly impressive things, and they reasoned that if they scaled this far enough, they could get very useful and very intelligent agents. And they went ahead and did that and gave us the glories of ChatGPT et al. Right behind OpenAI is the company Anthropic, which was actually founded by a number of people who left OpenAI. They have this model called Claude, which is also quite helpful, quite close to, I would say, ChatGPT 3.5, but not so close to GPT-4 at the moment. And below that, you have these big players, Meta and Google. Google has the model Bard, which you can also access if you just search Google Bard. It's at the moment not as good as OpenAI or Anthropic's models, but hopefully they'll catch up with due time. I'm not sure if that's hopefully, but maybe they'll catch up. And then Meta has released this model called Llama, which is this open source model that is quite actively used and researched in the open source community. Speaking of open source, there's this growing ecosystem of open large language models, which you can see there. You can see the Llama model, which is actually trained by Meta's team, okay, and a number of others. And while these are quite behind the proprietary models, these are quite behind the private models at the moment, there is a hope that they can catch up in due time. So now let's think about the areas of development. What are the key areas being worked on for the further development of these large language models? The first and maybe most important one is integration into apps. So at the moment, you kind of have to go to ChatGPT or go to your other large language model hub to use these models. But over time, they're going to be integrated directly into your email, directly into your computer's interface system, and so on. And this will make them much more easy to use. You also have the process of model fine-tuning. That is slightly changing the behavior of these models to fit specific purposes. For example, if you want to fine-tune a model to be a tutor, then you don't want a model that will always give the student the answers, which ChatGPT tends to do. You want a model that will nudge them to try a little bit harder when they get stuck, rather than just giving them the answer immediately. So for that, you have to fine-tune the behavior of the model a little bit. And this is a very active area of development. You also have model quantization, or really model compression. So at the moment, ChatGPT et al. Are really running on these large server farms. And it would be nice if we could run them directly on our computers or directly on our phones, because that preserves privacy amongst other reasons. There's also the area of training models on unique data, on data that is private to you. So you could imagine training a model on your own writing, so it learns to write in your style. Or the company Bloomberg recently trained a model on private financial data that it has. And the idea is that this can be a useful financial advisor. I'm not sure if that's for use internally within Bloomberg or for external customers, but that's called Bloomberg GPT. And it's a window into this future where we train models increasingly on private data that is unique to either ourselves or to specific companies. Or another important one is longer context lengths. So at the moment, ChatGPT 3.5, I think, has a memory of about 2,000 or 4,000 tokens, which is not that many words when you really want to use it for more intelligent tasks. So we would really like models that can read very long pieces of text and then make predictions based on that. But at the moment, we're quite limited on this context length question. Another important one is multimodality. So most LLMs at the moment are only operating with text. But if they could understand images and use those images to generate text, that would be quite helpful. Or if they can understand videos or sound, then you could have a kind of generally intelligent agent. This is something that OpenAI is working on at the moment. In fact, I think GPT-4 is actually multimodal. They just haven't rolled that out to the general public yet. And of course, we could just keep getting larger and larger models trained on more data and more compute. And we would expect this process to lead to more and more intelligent models. So speaking of larger models, here is a chart that shows the amount of computation used to train notable artificial intelligence systems. This is a chart from our world in data. And on the y-axis, you have the number of petaflops, which are used to train these systems. A petaflop, or a flop, which is a floating order operation or floating point operation, is a way to quantify how much computing processing power, how much compute was used in training a system. Okay, and as you can see, the relationship has been quite exponential, starting from when these models were being developed in the 50s and 60s. So this looks a little bit linear, but notice that the axis is exponential. So this is a very exponential relationship. And here's how much training compute GPT-4 used: about 10 billion petaflops. Now, it turns out that you can quantify the amount of training that is used to create a human being, specifically the amount of computation that a human does from birth to adolescence. You can do this in a kind of wishy-washy way by looking at the number of synapses in a human brain and how often they fire per second, and doing some kind of conversion from that to a flop. It's not perfect, but it gives you a sense of the amount of computation that's going on in our brain. It gives you a reasonable sense. And as you can see, GPT-4 was trained on more compute than the human brain is trained. Of course, the human brain doesn't start out as a naive neural net the way GPT-4 does. We start out with many billions of years of evolution have built in some existing intelligent structures into our brains. But just to give you a sense of really how powerful these models are, you can see that GPT-4 was trained on that much compute. And so maybe it's unsurprising that as we get to models that are trained with this much compute, we start to see this form of intelligence that seems roughly human-like emerging. And so it really does seem, and maybe this is a bit scary, that as the amount of compute we use to train these models approaches human level, so does the performance of the models. So here's another nice chart from our World in Data showing machine model performance over a number of benchmarks. So on handwriting, speech recognition, image recognition, reading comprehension, language understanding. And as you can see, starting from about the 2000s, these models have been catching up to human performance. And now on many of these benchmarks, models are outperforming the average human at these tests. And indeed, while ChatGPT is still quite stupid in many respects, I think it does write better essays in many domains than most people, and I'd include myself in that list. So as you can see, we're rapidly reaching a human level performance on a wide variety of domains. Okay. Now, I expect that the pace of this progress of these large language models and other models would generally tend to plateau at around human level. And the reason that should happen is because many of these training procedures depend on human data. So, for example, the large language models are trained on text from the internet or other corpuses that are generated by humans. So the knowledge they can extract is somewhat bounded by what humans have already figured out. Of course, this is not an absolute bound, so I don't expect these models to completely plateau in terms of their improvement, but I do expect some kind of slowdown in the pace of progress that we have seen over the past 1 or 2 decades. But it is important to note that just training on this next word prediction task really could lead to very complex reasoning. So here's an example that I got from, I think, Ilya Sutskever, who's the CTO of OpenAI. He says, imagine you're trying to predict in a detective novel, some spy novel, maybe something by James Patterson or something. You're trying to predict the end of this sentence, which comes towards the end of the book, and the killer was dash. Now, what sort of concepts do you have to get in your head to understand a decent completion for this sentence? You need to understand like all the characters in the book. You need to understand the motivations of humans. You would need to understand how the particular writer who's writing that novel likes to end his books. And so you need to understand a very large range of very complex things in order to just do this very simple task of next word prediction. And so in theory, if you could get a model that could actually predict the ends of detective novels, that would be a very, very intelligent model. So this could really lead to very complex reasoning agents.